All right. Let's see. Hold on. Let's see. I don't know how to. I wonder how I can make sure it doesn't spit out something super loud. Anyway, should be no volume loss. Okay, so we're gonna be talking about some R packages today. So let's view this full screen. Okay, so who's built an R package before? We got one. Great. Okay. So the question I want to ask you. So this
Before you get rolling,
yeah.
can I just make a brief announcement? Has everyone been assigned to a group? And you've been connected to the project composer? Okay, all right. I just wanted to make sure there weren't any hanging chats.
And they've responded. They responded to you.
Well, I don't know.
No. Okay. So if they haven't responded to you and you've emailed them once or twice, or it's been more than a day or two, drop us a line in an email and tell us that, so that we can hopefully try to link you up. Yeah. So
They haven't signed up yet, but you can talk to them.
Oh, sure.
All right. So this is a question. So for those who haven't or have developed an R package, what is it? Why are we doing it? Anybody? What's in an R package?
Collection of functions and data.
So, collection of functions. Yep. What else is in there? So you've used R before. What else is in an R package? Help. Okay. So some documentation. What else? Descriptions. So we said data as well. Vignettes. So a lot of these are more in-depth tutorials other than the help files. Versions. So it's not just the code. It's not just all the pieces of the code, but also the packaging system that tells you this version is different from the last version, or this version was updated. So you actually can keep track of what you're using, so that if somebody else installs this version and you install this version, then you at least have the same code, right? But if someone has a different version and their stuff breaks and yours doesn't, for example, it might be a versioning problem. Also, the big thing is dependencies. So if you write an R package, very rarely do you write code that doesn't depend on any other package, right? A lot of times you're building on other people's packages, you're building with tools that other people have created, right? So you also allow the dependency structure to work there. So when you tell someone install my package, you don't have to say, and they say, oh, my package broke, right? Or your package broke, it doesn't work on my machine. You have the ability, you already are ensured that they have all the other packages that you call out already installed. So when they've installed your package, the way R installs packages, it tells them, okay, you want to install this package, you need to install these other ones first, and then you can install this package. So these kind of components, for the most part, are what I would say encapsulates the entire essence of what an R package is. So we are going to make packages today, okay? So we're going to use RStudio and the DevTools package. There are other ways, other tutorials online on how to do R packages, how to make R packages. They're good. I'm not going to talk about any of them. This is one of the easiest ways that I can find to start and get an R package done quickly and off the ground with pretty much minimal tweaking, I'll say. So let's talk about some of the requirements for an R package. It must start with a letter. So you can't say, one or something. It can't start with a period. It can't start with an underscore. It has to start with a letter. That can be uppercase or lowercase. We'll talk about, naming things a little bit later. It can't have underscores in the name of the package. So this is a holdover from years ago. R used to use the underscore actually as the assignment operator. I know many people here either use equals or the arrow now to assign things in R. It used to use the underscore as well. That's why it doesn't allow underscores. It's kind of a holdover from the history and the past of R. It allows periods, though. So there are packages that are something like something dot something else. And also you can differentiate words, for example, using camel case. So I usually, if I'm splitting up words, I will use a period. So, if I said plot dot package, right? If it was a plotting package or something like that. Instead of writing plot and then a capital P for the package or something like that. That's just kind of a personal preference. I generally don't It's just easier for me to type things without uppercase letters, and it can have numbers. As most of you know, you probably have used ggplot2, right? You should know that there are numbers allowable in package names, and that's fine. Okay, so we are going to start one up. So everybody open your RStudio. We're going to go new project, new directory, R package. So I'm going to walk through with you doing this as well. Okay. So I already have an RStudio loaded up. So I'm going to say File, New Project, New Directory, R package. Sorry, I went through that pretty quickly, but I mean it's pretty visual. New Directory, R package. We're going to make a name. So because this isn't anything fancy or anything particularly useful that I'm going to do, I'm going to call it test. You should call it something relevant to your project, right? So I'm going to call test.package, let's say. Okay? And I'm going to say no source files in here. And right now I'm going to put it on my desktop because after this class I'm going to delete it pretty much completely because I don't care about this package. But for your stuff, put it in a directory that makes sense. Generally, also, just as a general rule, try to never have spaces in your directory structure or any of your folder names. So that's just a general good guiding rule for when you're doing a lot of stuff. There's a lot of reasons for that. And also, I'm going to click here, create a Git repository. So like all the things we're doing with Shiny and all the things we'll be doing, we should make a Git repository because it's good for version control, and it's also going to be really good when you want to distribute your package to others. GitHub really allows you to do that pretty easily nowadays. Okay, create project. So a couple things you should note. It reloads my RStudio. It opens this hello document. And also in the very top right-hand corner, you should see test.package. So if you've never used a project in RStudio before, pretty much if you click this, it'll show the projects that you're in. And if you see something up here, it'll just note to you that you're in this package. It'll also do certain things like it'll change the working directory. If you look up on console, right, desktop test.package, it will change the directory in which you're in so that it knows that you're working in this kind of project. So it's a good project management tool, but now we have a package loaded up and we can actually open that folder. So that's what I'm going to do and show you kind of what's in there. Okay, so depending on, so there's a couple of files up here that are grayed out because they're hidden files. The way I have my computer set up, it shows me all files in a folder, even hidden ones. But for right now, what you should mainly see are R, a description file, a test.package.rproj, that's the R project file for RStudio, and a man page and a namespace. So man stands for manuals, so that's where your help files pretty much lie. R, that's where all your R code is in there. And we'll talk about what a description and a namespace file is. But at the bare bones, and I'm going to show these folders, at the very, very barest, this is an R package. A description, and we'll open up that and tweak those things to talk about like who's the maintainer of the package? You. What's your email? What version is this package? What are the dependencies of this package? All that kind of stuff is going to come in the description. We'll talk about namespace a little bit later. And it's got the functions and it's got a help file. So this is pretty much a full complete package. Right? It doesn't really do anything right now. Pretty much the hello function, all it does is, if you look here, print out hello world. I'll make this a little bit bigger. But in essence, this is what a package is. Okay, so go back to slides. Okay, so we're going to configure the project a little bit. And so we're going to go to build, and we're going to say configure build tools. And this is configuring the RStudio project to build the package in a certain way that makes it easier. So a lot of these tools I'm going to be talking about with respect to documentation and building the package, checking the package, making sure the package works when you install it. This is how we can kind of configure that in RStudio to make it work the way we want. So we're going to go here. There we go. So we're going to go back to our RStudio. We're going to say build, configure build tools at the bottom. And we're going to get this screen. So one of the things that should be clicked is use the DevTools package functions if available. If you do not see that, that means the DevTools package is not installed on your machine. And I would just go install.packages DevTools at the console. So DevTools as the name suggests, is a collection of tools for developers, right? So it was written by mostly Hadley Wickham, but there's a lot of contributors nowadays, so you probably can assume it's a pretty good package. It's widely used. It is one of the most extensively used packages for development. The other thing you want to click here, generate documentation with Roxygen. And so we'll talk about what Roxygen is in a minute. But again, if you do not see this, you would have to do install.packages Roxygen 2. So if you don't see that checkbox or anything like that, you just have to install this package and then go back into the configuration and you should see it. Does everyone, when you go to this, does everyone see these two checkboxes? Okay, so we're going to click that. And this little thing is going to pop up. So it's going to say, use Roxygen to generate RD files, collate files, namespace files. We're also going to click vignettes, and we're going to click build and reload. So we're going to talk about Roxygen in a second, but essentially, like we said before, an R package is a collection of functions plus documentation. So you already know how to write R functions for the most part, or you know how to, X equals function with arguments. Roxygen is the counterpart, more or less, that allows you to easily write help files. And we'll talk about the format and the syntax there. Before kind of this revolution of making packages of sorts, you would write your R function and you would write the help file kind of independently. They'd be two separate documents and you'd have to make sure they were synced up. Roxygen will allow us to easily do that with a different type of syntax. Okay. So configuring our little package. All right, so we already went through this. So click all the boxes. So the setup. So in RStudio, when they give you this skeleton, is what they call it, the package skeleton with hello R function and hello.rd and the namespace file, it's configured in a way that doesn't necessarily assume you're going to use Roxygen. So right now we're going to delete the man folder and delete the namespace file, because when we actually are going to create this package, we want the documentation to be automatically generated from Roxygen. We don't want any of the stuff that was already in there to kind of gunk up our package. We don't need that file. And the namespace file, which again I'll talk about later, which pretty much tells R what are the functions that you created that you want the user to be able to use. We'll talk about that in a little bit more extensive detail. So, man folder, namespace. Oh, Jesus. Okay, so I have no idea. So I tried to turn it down, but it says it's 0, but the volume up here says it's really loud. Anyway, watch out for when I do stuff, apparently. Okay, so any questions so far? So we're just doing some bookkeeping and some cleaning up of the initial package that they gave us when we started a new one in RStudio. But we haven't really done anything. We haven't written any code. We haven't written any documentation. We're just kind of configuring it in a way that when we do write some code and some documentation, everything's going to work out okay. All right? So I want to talk about a little bit about RStudio projects and why I think when you're developing a package, this is the way to do it. So there's a go-to file function search bar in the top menu. So it searches through files in the package. It also searches for function names. And so what we're going to do is go to that. So this little thing up here, go-to file or function. So let's say you had 50 functions in your package. And you knew the name of one function, but you forgot which R file, which script you actually put that function in. That can be kind of a nightmare depending on how well you can search some of these files, things like that. But in this search bar, the nice thing about it is you can actually search for a function name. So right here I wrote hello. So you can see that these two little symbols next to the output, and one of them is a little script F, and the other one is a little R script file. So I mean script as in the font, not as like a script. So what you can do here is you can either go into the hello.r file, or let's say, again, you had a function that was in an R file that had 10 other functions defined. You could click this, and what it would do is it would open that file and jump to the exact line where that function was defined, which is really, really nice. The other thing it'll do is it'll search files within that folder. So let's say you want to open the description file. All you have to do is start writing in the first couple letters, and that's what we're going to do here. We're going to open up the description file for the package. So what do we see here? So we see a couple lines, and in the lecture notes, I talk about each one of these, but I'll talk about them kind of more interactively rather than going through the slide. So package, again, it's just the name of your package, right? If you named it, if you've done it, the setup like we've done, you don't have to change anything here. That's the name of the package. What is the type of this description? Package, you pretty much never touch that. You're saying it's an R package. That's all. The title, what the package does. So title case. So this is not a sentence necessarily. You would say, this is my package, but you have to write it in title case where articles such as of, the, and other things like that would be lowercase. Everything else would be title case. So let's see. Web application prototyping, right? Something like that. That would be the name of the package. So the version, so they give you a default version of 0.1.0. We'll talk about versioning a little bit later. The only thing you should really think about right now with versioning is when you update the package, when you update the functions or anything like that, you always change something about the version before you commit it, before you push it, for example, to GitHub. So that when someone installs your package and you fix something, let's say, and then it's still, like, let's say you're working in a team and someone says, this function doesn't work, okay? And they're in version 0.1.0, and then you say, okay, I'm gonna fix that, and I'll push it to GitHub, and great. Now reinstall it, and everybody's happy. Then another person comes along and says, hey, this function doesn't work. And you say, what version are you using? And you never change this version. It's a little bit difficult to 100% know which real version or what exactly is in that package if you haven't changed the version number. Okay? Author, who wrote it? So you just put your name. Package maintainer. For right now, you're the maintainer of the package, so you put your name, put your email. Okay, description. So, you write essentially what the package does. So, give me one of the projects that you're working on.
I'm building a risk assessment calculator for surgery patients.
So, for example, calculates risk assessment scores, let's say, for patients undergoing surgery. So, description is a lot more verbose than title, right? Also, it's written in normal prose, so sentences. It has to end with a period. These aren't things that will essentially make an invalid package, but it's good to just start from the ground up, knowing what these fields should be like. So, again, we don't necessarily have to keep anything capitals or titles or anything like that, and it's essentially a sentence or two that tells you what it does. Also, as the default tells you, there should be 4 spaces if you run on multiple lines. So sometimes you write a paragraph of what the description is to be very verbose, but if you have multiple lines, you should put 4 spaces before the next line to make sure that R knows when you build the package that this isn't another, that this shouldn't be attributed to another tag, right? It should be attributed to the description tag, so you have to do some indenting. So license. Okay, so I'll talk about all the licenses, and I won't talk about them in detail. More or less, if it's an R package, it has to fall under a certain set of open licensing. More or less, I use the new public licensing 2 or 3. That could be a whole nother class on licensing. I usually use GPL2 or GPL3. It's not 100%, it's not crucial that you know exactly what they do necessarily right now, but when you start to think about, productionizing this or releasing this in some capacity, you have to think about that so that if you allow people to use this for commercial products or some other things like that. But for now, we're not going to worry about it. Encoding and lazy data, we're not going to touch on those just yet, and we're going to talk about those a little bit later, but they essentially tell you that if you have data in there, load it with the package. All right, so any questions about the description file? So again, this is really, a description of your package, and also some metadata about the package that, it doesn't have anything about functions, anything like that. And we're going to talk about some additional fields in a little bit that are relevant to this. So like importing different packages. So again, we talked about the description file. So licensing can be one of these, one of this list. So again, the new public license, versions 2 or 3, the more liberal ones, artistic, so there's a BSD licensing and MIT licensing, and these are the ones, because R is an open source language, for you to get your package onto like CRAN or something like that, you need one of these licenses kind of for your package. So here's some of the fields that aren't included in that description file, and probably some of the most important. So, imports. So the way you delineate packages that you want to call functions from those packages, right? So let's say you want to use ggplot functions, right? You have to say imports : ggplot2. Let's say you want to import dplyr. You would say imports : ggplot2, dplyr. Okay? Pretty much depends is the same as imports, except when you put a package in depends, all the functions from that package are loaded when you call library on your package. So again, if I do library test.package and I said depends dplyr, all the functions from dplyr are loaded. So it's exactly the same, more or less, as if I said library dplyr, library test.package, right? Does that make sense? So if you put it in depends, when you load that package in, all the functions from the other packages that are in depends are available to the user when you load that package. Imports is different, and it's more lightweight. It says, yes, I want to use some of the functionality from this package, but two things that are different between depends. When you import in a package, all those functions are available to your functions when you call it. So let's say ggplot from ggplot2. All your functions can call ggplot. It's fine, right? It can call all the functions of ggplot within the code of your package. But when you load your package up, ggplot is not loaded to the user, okay? Also, what we're going to talk about is how to import only certain functions from a package. Usually, very rarely, do you want all the functions from a package. You usually want a handful, maybe 10 to 12 maximum from a package. And you don't necessarily, when you load your package, want to load every single function from another package, especially if that's a big package, right? So you can selectively import functions if you put them in the imports fields. So again, when we were talking about that an R package is data and documentation and functions, it's also dependencies. This is the dependencies. So there's another field that we're going to talk about very briefly. It's called suggests. That field is really useful when you say, okay, I'm not going to call any I'm not going to call any of the functions from this package in any of my code. But when I write an example, maybe there's a function that I want to write, that I want to use from one of these packages in my examples or in my vignettes, right? So it's a much weaker dependency in the sense, like, you write a vignette that does all these complicated things, it's really extensive, it's really, you do all these analyses, and you say, I want to use some of the other functions from this package, but it's not essential for a person to have that package when they're actually running my code. You would put that package in suggests. Okay? So those are the three pretty much most basic, the basic ways you import packages, other packages into your, you use functions from other packages in your package. Does that make sense? So this is how you say, I'm going to use dplyr, ggplot, you just put them in imports. So, which one do I actually, give me one sec, I forget which one I'm actually importing. So we're going to use, and more or less, you have to put in any packages that you're going to call anything from, including anything that's not the base, not literally the base package. So in our example, we are going to import, we're going to use the stats package. We're going to use histogram and quantile. So what we're going to do is import stats and graphics. Okay? So that's what we're going to put in there. So again, we're going to import the stats package and the graphics package, right? Because they're not base. Although they are loaded with R when you install it, they're not the base package. We're going to call some functions from there. And, but we don't want to necessarily load all the stats, all the graphics packages when we go to library or package. Okay. Alrighty. So again, we haven't written any code yet. We still have the hello there. So, sorry about that. So I'm going to do this on the fly because I forgot to echo this out. So we're going to make a file called a function called top. And give me 1 second. I'm just going to copy it from here, and I'll go through each line by line. Nope. Wrong one. Okay. Test that package. Okay, I'm just gonna put this right there. Okay. Alrighty. So I'm going to delete this file. So you can either do it over here. If we go into the R file, click delete. We don't need it. I don't care about the hello. So usually what will happen is if you have hello loaded up, RStudio is going to say, hey, this was removed from disk. Do you want to close it? You say yes. I'm going to do a new file, RScript, and I'm going to make a quick function. So I'm going to make a super simple function that's going to take in, let's say, a matrix X, right? It's a little bigger. So top is a function that takes a matrix X and a number, and what it'll do is it'll display n, number of rows and columns. So let's say you had a matrix that was 20 by 20 and n was 5. It'll print it. It'll do a histogram of that 5 by 5 upper left corner, and it'll print it out to the console. Okay, so just a simple function that is similar to head, but it actually just constrains the number of columns that you represent. All right. So right now we're going to save it. We're going to call it top.r. So at least the naming convention that I ascribe to is I try to have, for the most part, one function per file. If that doesn't fit with your way of thinking, that's fine. Some people write an R file that have a lot of functions of similar nature in there, right? But I always find it easier to say, if this is the function I'm naming, I name it, that name.r, and I keep one function more or less per file. So now we got the function. Let's do the documentation. So what I'm going to do is highlight everything in the function definition. So top equals function xn, all that kind of stuff. And then what I'm going to do up here is go to code, insert Roxygen skeleton. Okay, so we have the code, we just don't have the documentation yet. And Roxygen 2 will allow us to do that. So this should become clearer after we start writing the documentation and see what the output is. All right. So make this a little smaller again. So this is what we get. So title. So first off, you should note that it added this thing to the top of the file. So it starts with a pound or a hashtag sign with a single quote, a space, and then what I'll call tags, let's say. And those tags are referenced by @ symbols. So at the very first line, it has a title, or it says title. We're going to change that a little bit. But here it says param x, param n. So what it does is it parses this function. It parses this function and it says, what are the arguments of this function? So in this case, it's x. In this case, it's n. And it makes a line for those arguments. So the tag, though, even though in some respects I think it should be arg, there are reasons why it's called param, because these are the parameters of that function. Okay? Return, export, and examples. We will talk about all of those a little bit in detail. But for example, let's look at a help file. Let's say quantile. Quantile is always fun. So big letters. That's the title. So whatever we put there, that's going to look like that. So we wrote sample quantiles up here. It's going to come out big sample quantiles. Whatever we write in the description, and we're going to make specific tags for these, it's going to write that in the description area here. Usage, we don't have to worry about that. Roxygen takes care of that. You don't have to worry about these lines here. Arguments, whatever we see here, right, x, probs, na.rm, that is the equivalent of our params. So let's say x is a matrix with rows and columns. Okay? N is the number of rows and columns to print. Okay. So right now, okay, return, for this example, I gave a little weird one, kind of intentionally. So return, a lot of times, your function will return an object, right, to the user. So in this case, it returns whatever the output of print is. So technically, though, the output of print is nothing. Like if you said x equals print something, it's just a null. So in this case, we could say null, right? If we left it as is, if we leave it as is, I'm going to change it. So let's say we want to print or return XX. Okay? So in this case, since we've changed it a little bit, we're going to say this returns a matrix that is n by n. Okay? So return is again going to be in the help file. R does, like whatever you write in here, R doesn't actually like parse and say like, oh, you said it was going to return a matrix, it returns a list. It doesn't do any of that stuff. This is all free text that you're telling the user what is actually returned by the function. Okay? Again, this is all just documentation. So this up here is Roxygen syntax. This is what Roxygen will do. It'll read this whole file, look for these tags, parse it in a way that it'll create this help file on the right-hand side. Okay? So, export. Export means when you install this package, do you want the user to be able to call top or not? So if you want them to be able to call the top function, you say export. Sometimes you write a function that isn't ready, or it's kind of a helper function, or it's small, or it's kind of just, you know, a more or less a duplicate of another function from another package that you just kind of needed and tweaked a little bit. But you're like, if I put this in the package and people wouldn't necessarily use it. This is actually just a helper function for this other function. It's not useful. You wouldn't export it. So that means it's still a function that you could call in your package, but when you install the package and called library, a user wouldn't be able to use that function. So most of the time, though, you're going to be exporting the function that you have. So now, examples. So examples, if we go down here, are the examples for, so this is just, again, R code at the bottom. So let's say, let's make a matrix. Mat is a matrix, R norm 100, so 100 random normals, and row equals 20. Okay? So the nice thing about RStudio is it's smart. It understands Roxygen for the most part. So if you were in an example section and you do Command Enter, right, or highlight it and run it like you normally would in an R script, it understands that that's actual R code and you should run that. Bless you. So, but we haven't actually loaded this package. We haven't actually created this package in any capacity. So the top function doesn't really exist yet. So, okay, I will get to the examples after we actually build the package. So, but just remember, this is a area we can write some R code that will be run just to make sure your R code works, and also as examples to help the user to say, how am I supposed to use this function? These examples are the things that are supposed to help. And the last thing I'll talk about examples, you can put, let's say you wanted to show an example that someone could run on their computer, But when you're actually building the package and doing all the work or doing all the checking, you don't want it to be run. You could make a set of instructions or a set of R commands that aren't actually run when you do all the checking. So when we run the package, when we say check the packages for usability to make sure everything works, this line of the code will be run. Anything within these brackets of don't run, by definition, will not be run. All right. So let's take a step back. This is pretty much the majority of the work for an R package. Defining functions, right? You make your functions, you have the inputs, you have the outputs, all that kind of stuff. The documentation up here is the majority of the actual work going in to make it usable for someone else. So there is 2 fields we still haven't really propagated or populated. That is the title and the description, right? But once we're done that, as long as things don't change, as long as we don't add or delete parameters or arguments to a function, this is pretty much fixed, and you don't necessarily have to update it unless you change the function. So, last things we're going to do, we're going to add a title. So print the top of a matrix, and then I'm going to write a description tag. So something like, and you can write whatever you want here. You don't have to match what I do. So this function prints the top of a matrix. It is similar to head, but will only print a certain number of rows or columns. Okay, so again, it can go on multiple lines. It's free text. If I wanted to go on multiple lines for these things, right, a matrix with rows and columns, you probably could also pass in a data frame 2. If you hit enter, it goes on to the next line. It's okay. It's going to keep everything on one big block like it does in the help file here. So I like things that I'm writing to have essentially like, I want to be able to see everything. I don't want to have to scroll back and forth. That's why I might go on multiple lines. All right. So I know a few of you came in. So again, all this will be recorded. All the slide notes, the notes on the side should be relatively close to what we're doing here. We were just doing it a little bit more interactively, but more or less what we've done so far is we've created an R package through RStudio. We've deleted a couple things that by default they include there. We've changed a little bit of the configuration of the package when we build it, and we made a function here called top, which takes a certain number n that'll print out the number of rows, the number of columns. It'll also print out a histogram, and it'll return a matrix. We've added certain tags for the title, the description. We've populated all the fields to give the information about the function. Great. So I got the great job of teaching people documentation because it's so exciting, right? So okay. So now let's build the package. So there's a couple ways you can do that, but the build tab will do that. So load all, like all the functions in your package. Essentially, it'll just source all them in and say, these are all your functions. Build and reload will build the package and reload it in your workspace. I generally choose clean and rebuild so that if anything is in there that's kind of from the last build process, it gets deleted. More or less, from what I can tell, if you're not using C++ code or anything like that, clean and rebuild, build and reload are essentially, I did not hit that. Okay, or not, we'll do the exact same thing. So, I'm going to click clean and rebuild, and we should see, okay, so we see an error. Okay, so, invalid description, malformed maintainer field. I probably have some sort of typo on my name. So let's go back in there. So this is good because some of these will, it'll give you errors, and some errors are somewhat worse than others. If you mess up the description file, kind of all bets are off. You have to make sure that that works before kind of anything else. So let's go back to that and fix whatever I did. Okay, so I forgot to put a little bracket at the end of my email. So it said, I tried to parse your email, didn't really work, gave me a big problem. And then let's read a little bit more what it did. So Again, disregard this error for the description because I have a typo in there. But it will say writing top.rd, writing namespace, and it gave a little bit of warnings because the description file doesn't have a new line at the end of it. So if you actually see to the very, it added one. But you should always, for any type of text file that's just plain text, you should always have a new line at the end of the bottom. That's just kind of the way text files are supposed to be, apparently, in the world. So at least have one line at the bottom in there. Otherwise, you might get a warning. And then, so let's rebuild it when I actually have a legitimate description file so we don't see those errors. Okay. So updating any documentation, loading the package, documentation is good. So what this is doing behind the scenes, it is running this DevTools document function. And it's saying RD, so RD stands for R documentation. So when we go to the man folder for the manuals, anything that is a help file is located there. Collate, you don't necessarily have to worry about that. There are some instances where you really need a package to load functions in a specific order. That's generally a little bit more rare, but sometimes you need that to happen rather than alphabetical order. And it'll generate this namespace, which we'll talk about again in a little bit in a minute, which is really where this importing and exporting functions really matters. And then we don't have any vignettes, so that's not really important. And then after we build and reload, it installs the package, and then it tells you, package was installed, and then it reloads it into our workspace. So, if I write top, let's make this a little bigger. We see the function we defined, and we're going to put our matrix in there in a minute and see what the output is. Okay? So, again, this is an example. So top mat 4. So what did it do? I wrote, again, x equals to mat, n equals to 4. It shows me the 4x4 top of that matrix, and it does a little histogram of there. And it also printed it out. Okay? But again, since we changed this around, I'm going to assign this to x. Does the exact same thing, right? But I want to show you that x actually is returned from this object because when we go to the help of top, which we created. We're going to go to that. And we're going to see the corresponding output help file that was generated. So again, print the top of a matrix, right? We wrote that in the title. Everything's good. It put our description file in there. Usage is automatically generated from Roxygen. It took our parameters and our descriptions and put them in here. It says the return value is a matrix, which again, we could just double check to make sure that that was the case. And it's got our examples. And we didn't add anything in yet. So actually running the code. So if we say top mat 4, top mat 2, 4, we're going to add those in so that when we try to give the examples to someone, it actually uses the function that we're documenting. Right? This is a really, really bad example because you don't ever actually use the function you defined. It's just making a matrix and then doing nothing. All right. So there are some other things we will get to, but this is the most important. So this is how you make a help file. You need titles, descriptions. You need descriptions of what the arguments are that you need a user to put in. You usually want to tell the user, what are you getting out? Are you getting out a list of objects? Are you getting out a matrix? Are you getting out a data frame? Are you getting out a model? Are you getting out nothing? Right? But again, this is just a word description. If you say it outputs a list, but it actually outputs a matrix, R doesn't know the difference. We say export so that the user can actually use the function. I'm going to turn off export and we're going to rerun that code and show you that top is not going to be defined anymore. And then these are examples, and it can run for multiple lines. If you don't want something to run, you encapsulate it in this don't run little environment. Okay, so before I take out export, I'm going to look at one last file, namespace.
Excuse me.
Yes.
Before you go on, the 2 hashtags under examples, are those supposed to be there? Like,
Yes. So
not
in
run?
yes. So they demarcate blocks of code that aren't run. So if I put like more code down here, so like top mat 2, here, let me just rebuild it and look at the help file. So we see that those hashtags block out the code that is not supposed to be, or that is not run in an example. So let me show you so there's a function called example, and you can put in so you say example and then a function name. And what that will do is it will run the example down here. But when I run this, it'll run this line, will not run these lines and that line. So it's just a way of blocking out areas so that the user knows. So like examples can be very long, for example. And let's say you're saying like, I want to illustrate this aspect of a function, but I don't want to run this. Even though it illustrates that example, it might take a long time to run. So I'm just going to say it's there. You can take a look at it. You can copy and paste it. But I don't want to run it when I actually build my package. But then there's other stuff showing the other aspects of that function. I want to put them down here. So it tells you here to here is not run. Okay. So if I run example top, right, it'll run those 2 lines. I hit enter. It shows me a histogram. It didn't run any of these lines. It actually shows this little like hashtag D to say don't run. I guess not run. And then it runs the other lines of code. Okay. Okay. Namespace. Well, first things first. Let's read the top line. Generated from Roxygen, do not edit by hand. So we don't touch this. We're just going to look at it. I'm not going to edit anything about this. And we just see one line in there that says export top. So again, this is how an R package says, these are the functions I want the users to be able to use from my package. Okay? If we take this little line out here, I'm going to do that in rerun. Look back at namespace. It's gone. So if I say top, it says I don't know what you're talking about. There is no function called top because I didn't export it and tell R that that's a function I want the users to be able to use. So there's one more thing that we haven't done here. We didn't make the hist function. That's in another package. All right, so let's look where it is. Graphics. So, by the way, reading a help file, it says function name, and then brackets, and then the package that it's in. So we want to make sure. Let's say we had two packages that we loaded up, right? And both those packages, or another package had hist in it. And we wanted to make sure that we're using the graphics hist, the hist from the graphics package. Well, we have to tell R that we want to import from the graphics package the hist function. So just like the namespace tells you, or it pretty much tells the R package what are the functions the user can use that are defined in this package, it also, in the sense it exports things, it also tells R from other packages that I'm going to call on, what are the functions I want to import? What are the functions I want to use from those packages? So in this case, we are saying from the graphics package, we want to import the hist function. Okay? This isn't a very striking example because there aren't that many packages with hist as a function. Graphics is also one of the things that's loaded with R, but there are sometimes, a lot of times where, so let's say dplyr, which is a very common package to use. It gives you this kind of warning when you start up. It says the following objects are masked from package stats, filter, and lag. The following objects are masked from package base, intersect, set diff, set equal, union. So let's say in our package, we wanted to use the filter function. If we never told R that we definitely want the filter function from dplyr, then it would automatically it would assume that it was from the stats package unless we had loaded all of dplyer's functionality. And just to be 100% safe, you can also do this type of syntax where you say package name, : function name, so that you are 100% ensured, 100% sure that the function that you're calling is from this specific package. Again, this might not happen that much, but when, for example, before dplyr was really as popular as it is, there was a package plier, right, from Hadley and the gang as well. So the problem with that is those two packages have 10 to 15 functions that are the same exact name, but they don't behave the same depending on what you're working on. So these are type of instances where you had two packages loaded up, they both had filter, right? So let's say I wanted to use filter from dplyr, but again we know that the stats package has a filter function. I'm not going to use that here because it's kind of not appropriate, but if I wanted to do it, I would say dplyr filter xx, right? But if I said filter xx, that would still be okay because although the stats package has a filter function, we never told our package that we wanted to use the filter function from the stats package. We never said import the filter function. We never used the syntax. So this is the preferred way to do it. Import from package name, and you can put functions and functions. So for example, I want hist, I want the image function. You can put in a whole list of other functions down here. You say import from the package name, a bunch of functions that you want to import from that package. That is the preferred way of doing it. So again, your package is more lightweight. It only loads up those functions that are really necessary for your code to work. The shotgun way to do it is you just say import and a function name. And again, this is fine, but you only really do that if you really relied on more or less every function from a package, right? And again, that's kind of rare. And yeah, so you can do this, but you don't mix and match.
Sorry, so what is the difference between line 27 and line 22?
20.
With the colon?
Yes. So this is our code to call that, right? This is telling when I build my package that when my package is loaded, my functions can use the filter function from dplyr.
Okay, so it's just like the package syntax.
Exactly.
In line 22, whereas in 27, this is if I was like interactively working.
That's if you that code will run, right? Like if I took out obviously the.
But yeah, so in line 26, I guess I was just a little confused because some places that colon is uncommented. So
I'm just sorry. So I was just giving those as an example. I wasn't actually running that code. That's why they're just commented out. So again, these aren't comments, right? So this is a
no,
this
I meant
is
line 26 isn't commented out, but you're still using the colon.
So I'm just so let me give you a very brief example. I'm going to make another function in here called hist. I'm going to make a sham documentation for it. Okay. Dummy hist function. Description does nothing. Return, no, null. Export. Okay. So we're gonna do this and run top. Did I put export back in there? Yeah. So okay. So let's run this. Okay. We have a histogram. And in here, what actually happens? It takes the first 4 rows and the first 4 columns of that matrix. It subsets it, calls it XX, runs a histogram on it, and then it prints XX. Let's do it when I don't put those colons in there. So we get an error because in our function, in our package, we have another function called hist. So when this is called, it says you have a hist function. Well, which function? So graphics has a hist function, but in your package, you have a function called hist. So when you run this, it's going to say, oh, you're going to run this function. And when I pass in XX in there, it's going to call this function, say, there's no arguments to this function. It break.
I guess I was just confused why you weren't using the at import. I don't remember the rest of it, but why you weren't using that in line 26. Import from.
So again, this is the code. This is the documentation for it. So it's
okay.
sorry, it's just a separate.
Okay.
So anything above the function definition is documentation for either a help file or for the code for the R package to understand where the functions are coming from.
Okay.
Yeah. All right. So we can keep that function in there, right? That's fine. All right. So more or less, this is way past. So we have that. Okay. Did all this fun stuff. We already talked about that. Again, that's pretty much what I got. I had in the lecture notes. So again, a package is essentially a list of functions, some potentially, definitely documentation, potentially some data or some other type of objects. And in the next lecture, we're going to talk about how to, save a data set or have a data set in your package. For example, I know a lot of you are maybe fitting a model and you want that model to be contained in a package so that you can call it. You don't have to refit it or anything like that. You can just predict from that model. We'll talk about documenting data and things like that. But at the end of the day, this is the core of writing packages. A lot of times, if you're writing R scripts, you already have the functions done. It's just writing the documentation. And Roxygen really allows you to. So let's actually look at one of these help files. That's better. Okay. So this is the output from Roxygen. So what it does, it sets name, alias, title, usage, all these other things that you see in a help file. But you see it's in a totally different type of syntax, and it's in a very LaTeX type syntax, which is fine. But having this RD file, this documentation file, and this R file separated, I don't think is that great, because sometimes you can update function arguments, you can delete function arguments, or something like that, and you then would have to, remember to go to the documentation and change it. Whereas if the code and the documentation are all in one document, you say, okay, I'm going to add another parameter. Let's say m or breaks equals 10. Let's say something like that, and let's say I want to pass that on to the hist function. If I've changed it here, hopefully I would know to change it here. Right? So I say, oh, I know I just created something. So number breaks for the histogram. So now that the documentation's right above the code, so it's all in one document, right? So you know what you actually wrote, for the return, for the export, all that kind of stuff. And so it keeps them all in kind of one solid place. All right, so we'll get into, but at the very core, building and reloading. This is it. It's your package is loaded up. You can use the functions there. You can test them out, and then we'll talk about pushing that to GitHub and checking packages to make sure they're built right and stuff like that in the next kind of lab. All right. So, is there anything that so again, there are a lot of jargony words here for the most part, like a description file and a namespace. But in essence, all they're doing is configuring a bunch of R scripts together to tell R how this package is supposed to be built, what are the functions that are actually supposed to be used to the user, and other metadata like what version is it, some other descriptors for a user to see. Okay. Any last burning questions? Okay. Yeah, so I'll fix those notes and re-upload them, but for the most part, what we went through here is essentially that. If you have any questions, don't hesitate to shoot an email. And also, if you are trying this out and you said, I don't know how to do X, I'm trying to build an R package and I don't know how to do X, and it's something that we haven't covered yet, I'll try to cover it on Friday if you send an email. Okay? Thank you.
I didn't do anything.